start. Today, our lab is lab number 7, and the title of the lab is to convert system representations. And by system presentation, we mean transfer function, pole zero, and state space. And we will be using we will be using MATLAB to convert from a transfer function to pole zero and also to state space and vice versa. So, what is system representation? So, in control system, a dynamic system can be represented in three forms. Number one is the state space equations. The state space equation are actually the set of matrices, and these matrices are actually they define a system. Then we have transfer function. We have previously seen that when we are working in S domain, so transfer function is actually output by input of any system, and it has the S, basically the variable S shows the poles and zeros, and the numerator, in the numerator we have the poles, the number of S represent the poles, and in the denominator these represent, sorry, in the numerator we have zeros, and in the denominator these S represent the poles. Okay, so then we have also a pole zero representation. As we saw कि हमने एक ग्राफ देखा था जिसमें एक पोल जीरो मैप जिसको हम कहते थे, तो वहां पे भी हमारे पास कोई ना कोई सिस्टम की रिप्रेजेंटेशन आ जाती थी. सो दीज आर द थ्री मेथड्स के जिनमें हम एक सिस्टम को रिप्रेजेंट कर सकते हैं फॉर कंट्रोल सिस्टम. And now what we will do that we will uh, by using MATLAB we will convert from transfer function to state space and from state space to transfer function and pole zero. So let's see. Okay. So as I told you that we will be using MATLAB. So as you know that MATLAB has the capability of converting the systems very quickly, and you can also do it by means of some calculations, mathematical calculations, but that is time consuming. So if you are working on a number of systems, so it will be time consuming actually. So by using MATLAB, you can save your time and you can get your exact answer in a very quick time. So first of all, we have a scenario in which we want to convert the transfer function to the state space equation. So in state space, we have A, B, C, and D matrices, and these matrices actually these represent your numerator, denominator, and also there is a transmission matrix as well. Okay, so let's start here. We have a transfer function. So in the numerator we have 35s plus 7, and in the denominator we have s cubed plus 5s square plus 36s and 7. So first of all we will define the numerator, we will define the denominator just as we did in the last practical last lab, and we will make our transfer function and save it into a variable. I have saved it in a variable g over here. And then what do we need in the output is A, B, C, and D matrices. And these matrices can be easily obtained by using a command which is TF2SS. So TF2SS actually means transfer function to state space. And transfer function to state space of the numerator and the denominator will give you the answer in the state space equation. And then if you want to uh, make a graph of this matrix, like you want to get a state and the step response, so you have to save it in a variable and apply a state space function over it, and then you can simply get your response. So let's try it on MATLAB. Just copy this code. Here we have MATLAB window. Okay, I'm going to do it using the M5. Okay, so just remove these arrows. These are actually the command prompt. Okay, so meanwhile, if you have any questions, you can type them, and I will address those issues and questions. And we will also have a question and answer session at the end of this lab. So I've got my code here. I defined the numerator, the denominator, and then to obtain the transfer, the state space representation, A, B, C, and D. So TF to SS command, I have applied it here, and uh, and then simply I have applied the state space to the ABCD matrices, and then step as for the step response. So we'll just run this code. So now you can see that we have got matrices. Now this A matrix, if you see this A matrix, okay, so what you have here, you have a combination of the elements of denominator and numerator. And then we have this B matrix, and then we have a C matrix, and then we have a D. This D is actually a transmission matrix. So uh, there are you will be doing multiple calculations for these A, B, C, and D matrices in lab. But here, what we did by just applying a simple code, we got it. We got the representation of transfer function to state space. Okay, so we are not going to change the transfer function, but actually we are converting it to state space matches A, B, C, and D. And here you can also see the response of the system, and again you can find different parameters. Just right click on this and you will get peak response. Okay, this is the peak response. You can also get the cycling time of your system, rise time, and steady state. So all of these parameters you can you can acquire using the MATLAB. Okay, so this was first example, and if anyone has any questions, so you can ask me. If we have no questions, so we'll proceed to the next. Uh, okay. अच्छा, अजान कह रहा है आपकी स्क्रीन फुल नहीं आ रही। स्क्रीन, आई एम एक्चुअली working on MATLAB as well. So this that's why. ओके, तो आई होप कि अजान आपको अब नजर आ रहे होंगे। ये MATLAB का कोड एंड द रिजल्ट्स। ठीक है अजान। ओके सो okay, that is in the slideshow, so it's okay. I will just uh, I hope that you can now see the full screen now, because I was working on that MATLAB, so that's why I have to uh, close the slideshow. Okay, so this was the first example, and we got our results. Now, this is the second example in which we have to convert the transfer function to pole zero and then vice versa. So again, the same transfer function we will be using, which we used in the last example, and what we are going to do now is simply convert it into pole and zero. So for pole zeros, the first three lines are same, in which we have defined our numerator and denominator of our transfer function, and then we have saved it in G, which is a variable, and then the command the command TF to ZP, transfer function to zero pole. So this way, this command will convert the numerator and denominator to a Z, P, and K matrix, and this will give us poles, zeros, and constant of this transfer function. And then, if you want to convert it back from numerator from zero pole to transfer function, then you will use ZP to TF command on this Z, P, and K variable. Okay, so again, I will be using MATLAB. Need to close this now. I will add the command of clear all and close all as well, so that the previous readings and the previous work I have done is removed. Okay, so now what I have done, I have just added the command of transfer function to zero pole to my previous code, which will now simply convert this transfer function into a pole zero. So let's run the code. And now you can see in the MATLAB command window that the transfer function has been converted to pole zero. So you can see that there is a zero at minus 0.2000, and then we have three poles over here. Okay, so you can see that the denominator has the value of s cube. So s cube means there's a pole at s cube, there's a pole at s square, there's a pole at s. So, and then we have only one s in the numerator, so it means that it is only 1 0. Now, how you will confirm it? How you can confirm the location of pole zero, or you can how you will graphically see it? So simply there is a command of pz map, which I taught you in the last lab when we were doing the second order system. So simply write pz map of g. Okay, so the the transfer function is stored in G. So let's see the pz map of G. So you will verify which poles and which zeros are live. So as you can see here, there is a zero here. There is a zero at minus 0.2, and you can see in your command window that we have a zero at minus 0.2. Then we have three poles. Here is one, here is second, and the third pole is uh, overlapping with this zero. Okay, so the zero and uh, the pole are at the same position. So you can see that there is a pole at 0.1998. So it is actually very close to minus 0.2. Okay, so and it has no imaginary value. So it means that this pole is actually overlapping this zero. So both of these are overlapping each other. Okay, so this is your our pole zero map, and this pole zero map actually the values are shown in the command window. So I will just add the this line to your code, so you will be able to also get a graphical representation of your pole zero. And then there is another command over here, numerator denominator to pole zero. So that command is actually uh, what it is doing. It is converting your pole zero ZPK. Okay. So so this command over here, it is going to convert your Z, P, and K to a transfer function. So you can try it on any of your transfer functions to pole zero values. You simply go to here. So we have already got the values of pole zero. So we'll just use this command. And now this will give us our numerator and denominator. So as you can see that uh, and also you can make this you can save the system now uh, you can save the system in any of the variables, so you can save it in g1, and g1 is equal to tf of numerator and denominator. So here we got the same transfer function by this z, p, and k. If you want to show the also these values, so you can just write z, p, and k, and here you see we have got 0, that is the same values which we converted from that transfer function, and we applied command of zp to tf to convert it back to the transfer function. Okay, so this was about transfer function to pole zero, and if there are any questions, you can ask me now. There are no questions, so we will move to the next example. Okay, so किसी का कोई क्वेश्चन है जी? Okay, so questions so far? ठीक है जी, नोमान कह रहे हैं कोई क्वेश्चन नहीं. ओके, so it's very simple and I understand कि जल्दी आप लोग pick कर लेंगे. Now the next example we have state space to transfer function. Okay. So again we have to define the matrices here. This is our A matrix, this is our B matrix, this is our C matrix, and here there is no D. So D is actually 0 over here. So if you have any constant at the end of your uh, transfer of your matrices, which is actually your transmission matrix, so you will define it as D. But as you can see that there is no constant over here, so D is 0. So first of all, we will define our A matrix, then we will define our B matrix, and then C, and then simply there is a command of SS to TF. SS to TF command, what it does, it converts your state space equation to the transfer function. And then I also want to add a command over here of G is equal to, I'll just call it G2 is equal to TF of numerator and denominator. So it will give you a perfect value, like a proper transfer function this time. Okay, so let's do it on the MATLAB. Okay, so now I have defined my matrices A, B, C, and then D is 0, but still you have to define it in order to apply your function of SS to TF. If you don't write D over here, so this SS to TF might not work. And then we have saved it in numerator and denominator, and simply we can apply this function of the transfer function over here. अच्छा, Noman is asking कि अगर यहाँ पे डी मैट्रिक्स होता, डी मैट्रिक्स अगर होता तो सिंपली हम फिर उसकी वैल्यू लिख देते जी यहाँ पे, ठीक है ना, और डी में जो भी वैल्यू होती था हम उसको डिफाइन कर देते, जस्ट लाइक वी हैव डिफाइंड दिस ऑल ऑफ दी, ठीक है. सो एट राइट नाउ यहाँ पे कुछ नहीं है, मतलब इसके बाद प्लस और समथिंग होना चाहिए थी, लेकिन नहीं है, और मोस्टली नहीं होती. ट्रांसमिशन मैट्रिक्स बहुत कम आपको मिलेगी, कॉम्प्लेक्स सिस्टम में आपको मिलेगी जी. ओके, सो लेट्स रन दिस एंड चेक पॉइंट मैंने एक लगाया है यहाँ पे, ब्रेक पॉइंट अगर मैं हटा देता हूँ. ओके, so as you can see here, we defined our A matrix, we defined our B matrix, C and D is 0. Then we converted it to numerator and denominator, and afterwards we applied the function of TF to this numerator denominator, and here is our transfer function. And then you can also plot this function by figure step of G2, and also you can get the pole 0 map figure PZ map G2. Okay, so this is these commands, we used them in our last lab. Okay, so I hope you are familiar with these commands. Okay, you can also see the response over here. Okay, so I'll just add these lines to your slides as well. So you can easily. Okay, so here it is. Now, this is the last example of our today's lab. And here we have to convert between the state space and pole zero. So the same matrices A, B, and C, which we took in the last example, and D is zero here. So we will define A, B, C, and D. And then here the output we need is Z, P, and K. So zero poles and constant is the output, and the command is ss to tf, यानी कि state space to zero pole, and our inputs are a, b, c, and d. And similarly you can reverse this by zp to ss command. So let's try it in MATLAB. So we have already defined these matrices. So I will just add this command zpk ss to zp, is the command. And then if you want to show the pole zero map, so you have to add some command as well, like s is equal to ss a, b, c, and d, the same command used over here in the very first example. This one. Add some commas here. And then you need a pole zero map of that. So you'll confirm your value. Okay, so going to run this code now. First of all, I also need to clear all and close all. Okay, so here you can see that the A, B, and C matrices are now converted to a zero, pole, and constant. So the zero is at -4. So and then we have a pole at -3.5 and 1.322 imaginary, and -3.5 minus 1.322 imaginary. So let's check. Uh, okay, so we have these two poles, and there is a zero as well. Okay, so this confirms that the result is okay. Okay, so you can see that there is a zero at -4, there is a zero at -4, and then there is a pole at -3.5 plus 1.3. Here it is on the imaginary axis, and then there is a pole at -3.5 and minus 1.322 imaginary. So here it is in the lower section. Now, if you want to convert your matrices to a pole zero, so sorry, your zero pole to matrices, again, it is very easy. Just to find a zero pole and uh, use the command of zp to ss. So we'll also use this command over here. So as we've already got the zp and k, zp and k will be displayed, and just add the command of zp to ss a b c and d. Run this command. Now you can see that now these all zeros are now being converted to A, B, C, and D matrix. Okay, so let me show you your lab task, and after this lab task, I will take attendance. So the lab task, as you know that I'm not going to overburden you with these lab tasks, but these are actually a part of your labs, and you need to practice these in order to get command over these labs, and this is actually what you will be doing in your final exam. So therefore, I am going to upload these tasks on your uh, Google Classroom, but you have a deadline up to up to end of May, so you can submit it up to end of May. Lab task 6, 7, and onward, so you can submit them. So before 6, lab task 6 up to lab task 5, there was a deadline, but now I have extended that deadline to at to the end of May. Okay, so it's good if you practice it throughout this a week and submit it in a week's time. But if you don't want to practice it now, or you don't have MATLAB and some facilities, so you can do it by the end of May. So the first task here, it is actually what you have to do. You have to there is a transfer function, and you have to convert this transfer function to state space, and also plot the response of the system, and then you have to also convert it to pole zero, and you have to also get a pole zero map. So simply, this is just like first example, but you have to uh, add your third digit of your ID in this transfer function. So it will uh, make it a distinct problem for every student. Then 7.2, you have a state space equation. Matrices A, B, C, and D, and you have to obtain a transfer function and the step response and pole zero and a pole zero map. Okay. Then there is another state space equation, and you have to convert it into transfer function and pole zero, and then there is electrical system, and this electrical system this you have to obtain the state space representation. Actually, by applying some mesh or nodal analysis, what you do, you get actually the matrices, and those matrices are actually the state space matrices of this system. So simply you can search it in your normal nice book as well, and you can uh, go through it to how to find this the state space equation of this circuit, and then the once you get the values, you get the matrices, so you can simply put the capacitor C1 C2 as your ID23, and resistance at ID1 2 3, and inductance as well. So then you will be able to convert it to transfer function and a pole zero map. Okay, so this was all, and